Hello everyone. Today I am talking about the dataset of leaf image categorized and health and disease. The dataset organizes the image into train is 70% and variation is 15% and the test is 15% folder. It's ensure the proper direction and move image accordingly. So here you can see the I just import the variable and import the necessary and here the library from the sklearn. So here the original dataset directly I just use in my structure of code, and here's a directory for training, validation and testing. So then after we I go for the ensure the directory is exists. So it's a very important when the directory is not exist, so they couldn't find a data set in our code. Then after we just splitting the ratio is 0.7, 0.15 and 0.15. Then after we go for the organizing data set. So here the I just use the for the function. Then after we go to def, we create the function move image. Then after I just print the dataset restructuring complete. You can see the is running, the dataset is restructuring is completed. Then after I just go for the visualizing dataset distribution. So here you can see the three data bar chart showing the train, validation and test. So here see the class image count. So here the three type of bar chart is showing the train class distribution, validation class distribution and test class distribution. So here I can see, so here I can go ahead and I just use the data augmentation. So it is used for layer dot random flip and or horizontal. So here's the augmentation which is used for the data. What I say is image showing. So here the criteria how the image is showing horizontal, and the rotation is 0.1, random zoom is 0.1. Then after we go for the image processing. So I just using the image size 128 to 128 and the base size is 32, which is better suitable for me. So I just use the base size is 32. Then if I just create a image generator, it train the data. I just create a random values. So here you can see the rescale is 1 to 55. So it's represent the lighter to darker. One is showing very lighter and 255 is showing very darker. And then after we just create a data image data generator, then the trend generator, validation generator and test generator. You can see the output is data generator is ready, and upward is showing data image found belonging to 22 classes. Image found it to 5000 4502 image belonging to the 22 classes. Found 4463 images belonging to 22 classes. Found 4476 class belonging to 22 classes. Then after I just create a CNN module which is C I just create a CNN module which is help for max pooling layer to reduce the size and complexity, and a flatten and dense layer for classification, and drop out to avoid the overfitting, which is very important to over the data is not overfitting. Then we go for the softmax for multi-class output. The model is when the model is created, then after we go for the model dot compile, and the model and using I just using the model compile is Adam optimizer and categories cross entropy loss. So here you can see the I just use the model dot summary. Here you can see the total parameter and trainable parameter and non-trainable, which is in my perspective, which is very important to see the total parameter is showing, trainable parameter is showing, and non-trainable parameter is showing. Then after I just implement the defining callbacks, which is important too. And then after which is important, I just you can see the SUV logger. I just create a SUV logger. When the output is ready, the output is save in the CSV file. Then I just create a model.fit, and actually I just using three epochs. sorry for that, because it's taking too much time. So I don't have some much time to do. Actually, you can see that I just use a 3 epochs, which is very nice, and accuracy is 0.43, which is not bad. And the function to plot a simple prediction. Then after I just go for the plot training history. So here you can see the loss over epochs and accuracy over epochs. So here you can see the accuracy epochs is increasing, and the loss over epochs is decreasing. And then thereafter we go for the image for plant disease. So here you can say green text is showing is a correct prediction, and the red text is showing the wrong prediction. Then after we go for the plot training performance. So here you can see the model accuracy and loss model accuracy is epochs, and epochs are training accuracy. The red one is showing the training validation accuracy, and the blue one is showing the training accuracy. So you can see the model accuracy is showing high, and the model loss is going downward. So you can see the I just print the final training validation result. You can see the final training accuracy is 0.44, final validation accuracy is 0.59, nice, and the final training loss is 1.46, and the final validation loss is 1.29. Then after I just going for the hyperparameter. So I just using the grid set for increasing the accuracy. So here you can see the I just using the I just use import the Adam parameter grid and batch normalization. So here and the parameter grid is used for the dense unit is 100 and 256. So here you can see the so it is similar like a image size. So it is on the 128 to 56, and filter is 32 and 64, and the same like optimizer is using Adam, and I just using the epochs 2 and 4. So it is a correct way to use the epochs 2, 4, 5, 10, 15, 20, similar like that. I just using 2 and 4, which is more suitable for me because it's taking too much time. And you can see I just perform the grid search using the best validation accuracy. And sorry for that about the my code is ongoing. So you can see that it's almost around 452 minutes, so it is too much time taking, I just. And also is actually in my perspective, I just see the epochs is 2 into 4 times running. You can see the 0 epochs is 1 and 2, 2 and 2, 2 and 2 ongoing. So here the last accuracy is 0.32. So here you can see the epochs 2 and 2 is the best accuracy 0.59, which is nice. Then after we go for the, so here you can see the ISIS code was not running, and the final code is like this. Then after I just create from the backup, and I just use the let's see, I just use the model.fit, and the epochs is I just using the epochs 5, so which is accuracy 0.48, so which is nice. So if just so in my procedure I just using the epochs 5, which is best and giving the best accuracy is 0.45. Then sorry, um, then you can see that I just using the hyperparameter for the tuning the accuracy. So you can see is the ongoing code is running, and here I can also create a backup file. So here you can see the I use the hyperparameter tuning. So here define the hyperparameter grid. So its the code is ongoing, so it is taking too much time for me. So I just create a run, and actually I just use the epochs 2, which is not so suitable for everyone to using. This accuracy is around 28% for testing, and here the C is 0.25 for the final epochs is 2. And here you can see the accuracy in epochs in the loss and epochs. So it is showing the straight up and straight down, which is not actually is showing the line. And the previous one I just saw, it's showing the best graph. See the line chart is going band and up, band and up. So here is my full code of plant plant disease plant disease data set. So here, thank you so much, sir, and everyone to listen to me.